Hello future engineers, subscribers, viewers, and students. There is another video about construction of the load diagram and the moment diagram given the shear force diagram. So draw the load and the bending moment diagrams that correspond to the given shear force diagram. Assume no couples are applied to the beam. So in addition, I mark this as A, B, C, D, and the areas also included. So the shear force is in pounds, and this is stated that this is a parabola. So beginning with the construction of the load diagram, we have the beam. So from A to B, we have a smooth parabola with tangent, of course, from the figure horizontal at A, then it becomes negative 1,800 pounds at B, just to the left. So remember that the change in shear, negative 1,800 minus 0, is the area above. Since this is parabolic and parabola is second degree, it begins with 0 intensity because we have 0 ordinate here to a certain W1. So it is triangular above, triangular load. And remember the change in shear, negative 1,800 minus 0 is equal to the area of the triangle above. W1 is negative or it is positive downward. So negative 1,800 minus 0, and it is 1/2 of 4 feet times negative W1 or negative W. So W1 is equal to 900 pounds per foot downward as shown in the figure. Then at B, there is an abrupt change in shear, negative 1,800 plus definitely there is an upward force here, RB should be equal to 3615. So negative 1,800 plus RB equals 3615. So therefore RB is 5415 pounds as indicated here. Or another way is just to the right, 3615 minus quantity negative 1,800 equals RB. So RB is 5415 pounds upward. Then between from B to C, there is a first degree curve, which is a straight line, and it is a negative slope. The coordinate here is negative 885, and here is 3615. So the diagram above should be rectangular 0 degree because this is first degree negative. So negative change in shear, again negative 885 minus 3615 is equal to the area of the rectangle above, which is 5 times negative W2, and W2 is also 900 pounds per foot downward. So it is just extended as shown in the figure. Then finally, between C and D, there's no change in shear. So that means there's no load, there's no concentrated load, there's no load between C and D. So it's free here. And then there is an abrupt change in shear again. There should be an upward force, negative 885 plus that upward force RD equals 0 shear. So therefore RD is 885. Another way is 0 minus negative 885, so positive 885. So there is another upward force of 885. So that's the explanation for the construction of the shear of the load diagram. So this is now the complete load diagram with the reactions and the loadings. Then we proceed to the construction of the moment diagram. So beginning with 0, because the load here is, the moment here is 0, it's free. Then the area 1 is area of parabola, spandrel of parabola is 1/3 of 4 times negative 1,800, and it is negative 2,400 pound-foot. So connecting, we have negative 2,500 pound-foot. Connecting these ordinate to that negative 2400 with third degree curve, because this is already second degree curve. The tangent here initially is horizontal, and the tangent at this point is negative 1800. So in other words, the slope of the tangent to the moment curve is from 0 to negative 1800. So this curve is negative increasing slope. So negative increasing slope, because from 0 it is increasing negatively until the slope is negative 1800. So that's the negative increasing slope. That's negative 2400. Then to solve for area 2, let's solve for x1 first. The shortcut to the determination of x1 is we just divide the shear force 3615 by the uniform load 900, and it is 241 over 60 feet. Another way is you apply similar triangles. X1 as to 3615 equals 5 minus x1 as to 885, and you will get the same value of 241 over 60. This is based on shear equation, because the shear equation here is 3615 minus 900 x1, then we equate it to 0 because the shear is 0 here. Again, 3615 minus 900 x1 equals 0, so that's why x1 is 3615 over 900. So that's the explanation. It is based from shear equation, or you may base it from experience. But I suggest, if you cannot understand it, or if you do not know it yet, then you apply similar triangles. You will arrive at the same answer. So that's why area 2 is equal to area of this triangle, 1 half of x1, 1 half of 241 over 60 times 3615. So that's why it is 7 to 60.125. So negative 2500 plus 7 to 60.125 is 4860.125. So joining these 2 points with initial slope here is equal to 3615, that's almost vertical tangent. Then the tangent here is horizontal because we have 0 shear. So connecting them with a second degree curve or parabola, it is this curve here. Then between negative 4860.125 plus area 3, area 3 is 1 half of 5 minus x1, then times negative 885, so negative 435.125. So 460.125 plus negative 435.125 is 4425. So the tangent here is negative 885, the tangent here is 0. So we have negative increasing curve again, negative increasing slope of the tangent, which looks like that, but we just connect that 2 points. That's it. Then finally, because this is 0 degree, this should be as first degree line or curve. So for 425, the area of this is equal to, of course, that area is simply 5 times negative 885, and it is negative 4425. So 4425 plus negative 4425 is 0. So joining these 2 points with just a straight line. So that's it for this video.